Good morning, everybody. My name is Ray Admire. I work for Lockheed Martin. I represent the DMIS Metrology, or Dimensional Metrology Standards Consortium. Different levels. One being for as the treasurer, and the other is the chairman of the Quality Measurement Standards. At Lockheed, I lead two different collaborative efforts, one of them for CMM programming, and one of them for first article inspections. And today, what we will demonstrate today is a QIF format. The QIF allows us to provide interoperability between different vendor solutions, all the way from defining our requirements, planning our requirements, and getting inspection data, and providing results and analysis, including a first article inspection. The QIF itself is an emerging standard. It's a neutral file format, and it's being tested today by 7 vendors here in the DMSC booth. It will save you time, and it will save you money, and it helps ensure accuracy of your data in the first article, statistical process, and other analysis tools. Today what we're going to do is we have a small 3D part, as shown on the screen. We're going to show that we can measure diameters, maybe lengths, widths, position of location, and other items. So we have 2 different measurement tools being displayed today and being demoed. One is an equator, and one is a pair of calipers. And so we can generate a QM plan. We can take that plan and execute a measurement. We can obtain the results, and we can go downstream from one vendor to the other's solutions, whether they're proprietary or open source like a DMIS code. And then in the end, we will generate first article inspection report. And several companies will work at different aspects. So we have interoperability of data. We will have several plans, and all these companies are producers of plans on the top, and the bottom are consumers of those plans. And then again, on the results, we have several companies that will show their ability to display the QM results, and we have several companies that will display or perform consuming of those reports. So at this time, we're going to pass the microphone over to Curtis Brown of Honeywell.
All right, thank you, Ray. My purpose of the demo is to kick it off with our use case. Our use case is to generate a first article inspection. And once again, my name is Curtis Brown. I'm from the Honeywell Federal Manufacturing Facility in the Kansas City area. And I'm going to play the role of a quality engineer at the very beginning, and my role is to create a quality measurement plan. And this plan identifies what needs to be measured. Now, sometimes plans include how to measure, but in this instance, for our demonstration of the quality information framework, we are going to generate a what to measure plan. Honeywell believes that the incorporation of the quality information framework, and as it progresses as an American and ISO standard, will make our manufacturing faster, better, cheaper. So here's an instance of a product called Feature-Based Tolerancing Advisor and Feature-Based Measuring Advisor. As you can see here, we've brought in the solid model of the part. We have also gone through the process of tolerancing, and as a good quality engineer or process engineer, I'm going to understand and know this part. And so I'm going to look at all the characteristics, all the tolerances, and in this case, I have a couple things that I want to bring to your attention. We have some people like to balloon their drawings, but really what that is a key characteristic, and so we want to have a unique identifier associated with that. For this instance, we have a size tolerance with a key characteristic of 12, and then we also want to definitely capture whether this key characteristic is a major, minor, or a critical feature. And that's really key for me, because if it is critical, then doggone it, I'm really going to measure that, get an opportunity to take care of that aspect. So what I'm going to go ahead and do is create a measurement definition. I'm going to be analyzing and looking at the tolerance definition, and right now I'm automatically recognizing some measure features and some measurands. Measurands are things that I need to measure to validate this part. One thing in reviewing this, oftentimes I will want to do a check. I'm going to do my own check of the tolerance definition. So real quickly, I have a quick understanding of how well this part was toleranced, and that gives me some feedback of how I want to measure it. So for my role in this demonstration is to create some quality measurement plans. So I'm going to export some plans in the QIF format that's being talked about today. Part of that plan requires some traceability information for not only the part, but for the first article inspection. Here's a quick dialogue of some information opportunities for you to enter that. Serial number, report number, who's inspecting it, things like that. I'm just going to go ahead and take the defaults. And now I'm been asked to save this file. It's an XML format. And I'm just going to override an existing XML format. And what it's doing right now is it went out, interrogated, and found all the different measure features, all the different tolerancing characteristics, and put it into the XML format. And it made a sequence list of all the features or the characteristics that needs to be measured. So real quickly, we generated an XML file that consists of 1,266 lines. And if you had an opportunity to, you would look through this and you can see feature instances and tolerance instances and the relationship IDs. And these IDs will be passed on to the measurement and the measurement results, and we'll have connectivity from the plan to the results back to the first article inspection. So that's part of my role, and I'm going to pass it on to Sergey, and he will be demonstrating something similar with his tool.
We start with a native CAD model that, in this case, includes annotations. We produce Siemens program for it. Then we produce QAF standard plan, and we pass it on to the Siemens vendors. So I will show you how the program is going to look like, and this is how the program looks like. This is what the machine is going to be doing, and like I mentioned, this program comes out in the DMIS standard format. Okay, so. And the QAF plan looks like this. It's a list of inspection characteristics that we need to obtain. We need to get the results back from the machine. Okay, so this is what we're going to be doing. We're going to bring back the results in the QAF standard form. I'm getting these results from the Mitutoyo machine, and when we import this in, we see that there are parameters that are coming in. The serial number of the part we inspected, the measurement tool, and we can even put the name of the inspector. So now my results are coming into the plan, and in a matter of a few moments, we will be able to prepare the first article inspection form, and we can do it almost instantly. PASIMAM is QF compliant and can bring in inspection plans. We can generate inspection plans in the QF format, as well as bring in results and produce the results for further statistical analysis and so forth. So this is the inspection life cycle in a nutshell. Thank you.
Thank you, Sergey. My name is Robert Brown. I work for Mitutoyo America, and Mitutoyo is committed to the Quality Information Framework as an interoperable standard because our customers' problems ultimately become our problems. And this saves our customers time and increases their accuracy in data from CAD model or drawing to the planning stage, to the execution stage, and to the data analysis and reporting stage. So what I'm going to do here with MeasureLink, which is a statistical process control application for data acquisition, management, and analysis, I'm going to bring in a quality measurement plan from the Lockheed Martin part. And you'll see within just a second, I was able to bring in all of the characteristic labels, all of the tolerances, and all of the nominals for this part. The only thing I have to do to be able to collect data against it is tell it what sensor or what dimensional metrology equipment I plan to use. And for the sake of today's demonstration, I'm going to use a 6-inch caliper to inspect some diameters and slot widths on this part. See, now that I've initialized the run, I can go ahead and begin collecting my data for a first article inspection. Of course, I could continue with the slot widths, but for the sake of demonstration, I'll keep this short. And of course, finally, for downstream applications that might be AS9102 first article inspection reporting applications, I would export these quality measurement results simply through an export wizard. And one example of a first article inspection is the MT Connect client. This is actually a web service. These folks are found in the Emerging Technology Center, and this is all published through an MT Connect agent. And you'll see down below I have Form 1, Form 3 data from an AS9102 report as an aerospace standard. With that, I'll pass it downstream to my colleague, John Horst.
Thank you, Bob. I'm John Horst from NIST. That's the National Institute of Standards and Technology. And how NIST helps this effort is we try to make sure that the standard is validated against manufacturer requirements, usually represented in standards like the first article inspection and the GD&T standards. And the other thing we do is we seek to verify that the implementers implement it correctly according to the standard so that you can have interoperability. And the last thing we do is we're the librarians of the standard, and so we do the information modeling. Now I'm going to put on my Discus hat. Bob Roush of Discus has done a lot of work implementing this standard and this emerging standard. And if you can look at this chart here down at the bottom, Discus consumes the measurement results information formatted in QIF into their software. And so I'm going to give a demonstration of that with their Discus tool. So here you see the model. So it has the model in there and it has the nominals. And the panel, it's been ballooned. And the panel on the right will soon receive the QIF formatted information from the caliper measurements that you heard Bob Brown mention. So there it is on the right. And down below also there's a matching of the results against the nominal values. Now the user is able to add additional information. This differentiates tool to tool. The standard does not constrain the innovation of an individual tool vendor. So now the goal in this demo is to produce a first article inspection report. So here you have the report being produced as an Excel file. The Excel or PDF is not part of the standard. So you can report it any way you want and print it out as paper. So here's the Excel file. And that's the end of the demo. Thank you so much. And I give it to Peter of IPI Solutions.
Speaker, please.
So I'm Peter Swanderer from IPI Solutions. Our software applications are all about quality reporting. We've come and joined with the guys from NIST and DMSC and all the other vendors here because we're concerned about the interoperability aspects. We spend time and effort generating translators to bring in CMM data and data from other automated devices into our software tools, which takes us obviously time and effort, and reduce that effort or eliminate that effort using a standard QIF format. That's going to make our tools leaner, and also it's going to save money for our customers. So I'm going to show you how we've implemented the QIF, the Quality Information Framework, to be able to generate quality plans for others to use to populate with results. And also I'm going to show you how we can bring in results files from other vendors' applications. So I've got our part here that we've ballooned within our application, and we could go in and we could populate that part with some results. But what I'm going to do, I'm going to use this as a quality plan. So here's the data, and what I'm going to do, I'm going to just close that part, and I'm going to use that to generate a QIF format XML file. So I'm going to export the data, creating my QM plan. I'm going to just make it plan number 2, because I did one earlier. So now it's exporting that data in a format that is suitable for sharing with another vendor. And just to show you that, if I go and show you the XML output, so this is what we've created. So we can translate or transfer that to another vendor's application, and they can read that in, and that is the quality plan. The other way is for us to collect a set of results from someone else's measurements. So what I'm going to do now is create a new part. I'm just going to select the customer requirements style, and here we have an empty part, and I'm going to read in someone else's result set. So using our QIF application, I'm going to open, I'll pull the results in from this Renishaw equator machine. So here's the Renishaw file. It's reading in that data from the QIF format. So here's all the data from the Renishaw file. And if I click to update the part, it's as simple as that, just a few seconds, and that's generated all the information for the defining the part and all the features. So if I bring in some forms, let's say we're going to do a first article, typical of an aerospace supplier, and here we have the forms required by their customer. So an AS9102 first article, some of which still needs a little work, some items just to sign off this report, and here's the measurement data coming in, and if I just update that, we'll see we've got some results in there, and it looks as though we've got a good part, so that's always pleasing. So that's using the Quality Information Framework to both generate a plan for someone else to populate with results, or we've used someone else's results to generate our first article inspection report. Thank you.
The next thing we want to point out is the equator. The Equator is a Renishaw tool. So it consumes some DMIS part programs, executes through I++ DME, and then generates the QIF results, which allows us to stay DMIS compliant on the front end and QIF compliant on the back end. So again, what we've done, what we've demoed here are several different vendors generating plans, at least 2 different systems that will output a QM results, and several different applications that will consume those results and provide us AS9102 inspection reports, and then most of those systems will also do SPC reporting. So the QIF is an emerging standard. It's a neutral file format. It was tested today and demoed by 7 different vendors. So if you watch for QIF to save you time and money. The DMSC is an ANSI-accredited standards organization. It's the same organization that brought you the DMIS standard to ISO, and also will generate or take the QIF standard to an American and fast track to ISO. So please visit our website, qifstandards.org. Again, as a Lockheed Martin representative, I can tell you this is going to save us time and money. It's going to allow our supply chain to provide us our results in a standard format. All you have to do is go to qifstandards.org, contact your software providers, and ask them to support the standards. Thank you, everybody. Thank you for our participants today, and have a great show.